Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Thank you, Anna. Hello, everyone. Good morning, good afternoon, good evening from me as well. I'm Guilherme Martinez Roura from the International Telecommunication Union, and I would like to welcome you all for joining today's AI for Good webinar on fighting wildfires with intelligent robots, organized by the ITU, and the first Robotics for Good session of 2023. This session is part of the AI for Good robotics programming track, exploring how AI-powered robots are helping to unlock our human potential and advance the United Nations Sustainable Development Goals. We have a distinguished set of panelists today, but as always, we are counting on you, the participants, to help create a very interactive session. Without further ado, I would like to introduce our moderator today. His name is Kirk McKinsey, and he's the president of McKinsey Smart Technologies. Kirk, welcome, and the floor is all yours.
Thank you so much for the introduction. Ladies and gentlemen, hello and welcome to the AI for Good webinar on fighting wildfires with intelligent robots. Thank you for joining the discussion and the important intersect to Sustainable Development Goals. There are many SDG opportunities: industry, innovation, infrastructure for life on land, climate action, sustainable cities and communities, and the partnerships that enable those goals. As a former active duty firefighter and an inspired smart technologist, I'm very interested in what I'll learn today, and I hope you are too. There is certainly a global need. Based on the Center for Fire Statistics from the International Association of Fire and Rescue Services, in 2020, there were more than 10,000 fires every day, contributing to more than 50 lives lost each and every day. The target use case for intelligent robots and AI is diverse. From wildfires that threaten historical landmarks and communities around the world, it is the humans we most hope to protect. This is the core of our experts, the ability to save a life from the ravages of fire and to make our community safer, more digitally intelligent and resilient. So much to cover today. It's my privilege to introduce the first speaker in our expert field. Manon Vermenouze is the Director of Communications and Public Affairs at Shark Robotics. She is also Vice President of the European Association Drones for Sec, or Drones for Security, and an advisory board member of the International Observatory for Diversity and Artificial Intelligence. She has experience as an economic journalist and a member of the Association of Economic and Financial Journalist Boards. Manon, over to you.
Hi, Kirk. Hi, everyone. I'm so delighted to present you today the Shark Robotics activities. I will share you my presentation. So Shark Robotics is a leader in unmanned ground vehicle for dangerous areas. It's a company which was founded in 2016 in France by Cyril Cabrera, a former human team leader in the French army. We design and manufacture multi-mission UGV in firefighting, nuclear, defense, and space fields. And our goal is to intervene close to the danger to protect humans, the environment, and the companies. And today, and in 2023, we are a team of 50 people with the mastery of the main pillars of robotics, It means mechatronics, software, artificial intelligence, and lithium-ion batteries, because our robot runs on electrical energy. We built strong partnerships with the French Federation of Firefighters and the Nuclear Accident Response Group in France. I let you discover our last video, where we follow the Paris Fire Brigade during the training in the tunnels of the Greater Paris with the new metro lines. I introduced you our most famous robot. It's Colossus. It's a 500-kilo robot, a big one. And it's a multi-mission robot, which is very interesting for the firefighters because they can use in different kinds of missions. So today, our robots are remotely controlled, but we try to develop new AI bricks to help the firefighters during their mission, to support them and not to replace them. It's important to say that. And we work too on very resistant electrical batteries to be the most safer possible for the firefighters. So you can see, you can transport equipment, you can evacuate wounded people. And now we are in Marseille, in the south of France, and we follow to all the trainings of the Marseille Fire Brigade. And we have a lot of cameras, of thermal cameras, zoom cameras, with a lot of sensors which can help the firefighters during the ignition. It can climb stairs too, and it can be very useful in outdoors and indoors environments. That's the difference for our Shack Robotics robots. So how all of robots were developed with the dialogue with the firefighters. Colossus was the first robot developed thanks to a collaboration with the Paris Fire Brigade, and now they have six Shack Robotic robots. And we have a bottom-up approach. It means we innovate as close as possible to operational needs, thanks to links with many rescue services in France. And now we delivered more than 100 robots in 15 countries. We have a partnership in innovation with some fire brigade, and we have some AR bricks, as I said previously. So today we propose 3 kinds of robots: Colossus, Rhino Protect Alligator. For the story, Colossus won the Innovation Technology Award by the American Association of Mechanical Engineers. And they are very useful because they can be deployed very rapidly, very quickly. They are multi-missions. They have a lot of autonomy. It can be very useful, like in the Notre Dame Cathedral fire in 2019. We talk about it after, and they are very robust. So to talk about the most famous example of the use of a firefighting robot is Notre Dame in 2019. So the Colossus were engaged at 11 o'clock by the Paris Fire Brigade. There was a low risk of collapse of the nave and melting boiler structure. And it intervened because it was too hot. The temperature was too high, and it intervened during 10 hours under 800 degrees. So the water cannon module were used, and it allows to contain the fire, prevent a landslide, and lowering the temperature in the nave. Other example, like an underground car park fire in Kite near Paris in December 2020. And it can be very useful in the car park fire because Colossus have a lot of sensors, cameras, and it can be the eye and the arm of the firefighter. And another example is the wildfire in Marseille in January 2021, when he was very helpful for the Marseille Fire Brigade. Other example, it's now all the robots are very useful for warehouse fire. And in Paris and Marseille, every week it intervenes for a warehouse fire. So it's, for me, the most relevant example of for firefighters robots. Thank you.
Thank you, Mano. Thank you so much. Very inspiring. And while I didn't get to use your Shark robotic systems while I was still a firefighter, I look forward to having a chance to demoing them someday. Thank you. Our next speaker is Bart Slogger. He is the CEO of Perspective Robotics AG, or Kite. Kite develops and manufactures cutting-edge tools to assist public safety teams with elevated situational awareness. The autonomous systems inform public safety teams during complex, mission-critical situations. Bart maintains a dual background in engineering and finance and a variety of C-suite roles, addressing multi-factor challenges and implementing solutions. Bart, thank you for being here for today's discussion, and please tell us about the Kite solution set.
Thank you for having me here today. Let me bring my presentation. So what you see here is our actively tethered drone. We call it a Kite, with which Kite offers a situational awareness solution for public safety teams, delivering mission-critical information from a bird's eye perspective. Since the Kite is autonomous, so no pilot needed, the main experience for the firefighter is mission-critical data. On scene, this can be displayed on many different devices, like the tablet shown here, or on a big screen in the command vehicle. The data can also be easily shared with colleagues, either at the fire station or on their way to the scene. So the Kite, as an intelligent robot, provides with and without AI data to help firefighters to save lives and to stay safe. Kite started as a spin-off from ETH Zurich, and we currently have about 50 colleagues based in Zurich and Boulder, Syracuse in the US. Our mission is to help public safety teams save lives by providing the best technology and instant, actionable intelligence to first responders. Apart from a strong shareholder group, we partner with two big stock-listed market leaders, which is MSA for the fire business and Exxon on the public safety law enforcement side. So you can imagine that this, for Kite as a smaller company, has a great impact on our sales and marketing activities, the product awareness, and on positioning the Kite within the different markets. With this video, I would like to show you how our Kite provides situational awareness and supports fighting wildfires. When firefighters arrive, they want to do two things at the same time: immediately come to action and keep an overview. With a launch within 15 seconds and no need for a pilot, we offer a solution for this. All information is displayed on a tablet, which also can be used to instruct the Kite. At a height of 45 meters, which is about 150 feet, and with a dual thermal and EO camera, the Kite delivers mission-critical information from a bird's eye perspective, even in difficult situations. This shows a search and rescue scene related to an accident, but the same can be applied to saving lives in a wildfire situation. Upon arrival, just one person will quickly launch the Kite, which will provide a team instantly with situational awareness, and they are ready to act. The thermal low-light video stream supports the firefighters, allocating different victims. During wildfires, it even shows them the most suitable way to reach the person. That is why our mission is to save lives, but also for rescue teams to stay safe. This can all be done by just pushing a start button. In the last part of this video, I would like to highlight some additional functionality and how AI comes into play. Since our Kite is an actively tethered drone, it can stay airborne for as long as the mission requires. By connecting to other devices, like equipment from our partner MSA, we're able to allocate the different firefighters and give them guidance on hazards. With the overview, the team can better judge how to approach the wildfires and reduce water consumption. And of course, our Kite is capable of flying in all these different conditions. To summarize what I just showed you in the video, all you need is a tablet, a rooftop box, an active tether, and a Kite. Very simple. Energy goes up and data comes down via the tether. So no battery swaps and guaranteed secured data. There are circumstances where the rooftop box might not be sufficient, like if the truck with the rooftop box is not available, or if it cannot be parked in the right spot. Or depending on the size of the wildfires, multiple kites are needed on scene. So therefore, we have developed also a transport case as a flexible mobile solution. And all you need is electricity. Our Kite is full of AI and mainly therefore a safe solution. The autopilot controls the Kite, keeps it in a stable condition over the ground station. With 6 engines, there is a high rotor redundancy. We don't need GPS to fly. And if there's too much wind, the Kite will first lower its height, or if necessary, land. In case of an electricity cut, Kite will land after 15 seconds. And on top, there is an emergency land button. Most of the AI is in our hardware, like the autonomous flying. This means that for our engineers, the hard part is solved. And already today, we're not just showing videos, but process the data in an intelligent way. This year, we will further focus on maximizing the application of the data. Tracking people could be an option, or monitoring the fire lines at wildfires. Our thermal camera can register the soil temperatures and show not only the differences, but also the trend. When designing the Kite, we already took the need for heavy data processing into account. Therefore, every Kite has high-end computing capabilities in its ground station, which is an advantage over the free flying drones. Another example is that we're currently doing a pilot project with a European university on live GPS positioning to be integrated with a moving map display. This would allow the user to point to an object in the video frame and compute a latitude, longitude coordinate. This means that we can accurately pinpoint the water drop locations for the water bomber aircraft. I would like to finish my presentation with a video of a real emergency. What you see here is a house on fire, and on the video on the right, you can see that there is a lot of smoke, which makes it difficult for the firefighters to judge the situation. With a thermal video, the team can detect the hotspots and direct the fire hoses. This will help them not only to more effectively fight the fire, but also to reduce the water consumption. So apart from a safety aspect, our Kite is also contributing to a more sustainable operation. Thank you.
Brilliant, Bart. Thank you so much. What inspiring capabilities, elevated capabilities. And to me, both systems provide the situational awareness to make actionable intelligence at the time of intervention. Excellent. Thank you so much. Our next speaker is Assistant Chief Wade White. He has been a Los Angeles City Fire Department member for 35 years, and he is the Assistant Bureau Commander for large-scale incidents in downtown Los Angeles, the Port of Los Angeles, and Los Angeles International Airport. Chief has past responsibility, including engineering, purchasing, and maintaining over 1,400 apparatus and personal protective equipment for 3,350 firefighters. Chief White is the leader of the 80-member Federal Urban Search and Rescue Team Task Force 1. He's deployed to various complex incidents, including the World Trade Center attacks and Hurricanes Katrina, Harvey, and Irma. Chief White has served as a member of the Executive Board of the California State Firefighters Association, as well as the Chief Officers Association. Chief White, thank you for being with us today, and please tell us about the good work of LA City Fire Department.
It's an honor to be here with you, colleagues, and all the participants in this webinar. Thank you. Get it? So my colleagues here have put together quite a bit of technology, intelligence, and equipment that we're utilizing within the Los Angeles City Fire Department and throughout the region. Just a quick story, Mano, her robot Colossus, was the inspiration for us to head in this direction with the Los Angeles City Fire Department. We saw how well that robot worked at the Notre Dame Cathedral in 2019, and we went ahead and purchased one ourselves. And we're actually using that robot quite often. We've been deploying it about once a week, maybe twice a week, and I'll get into how it's benefited our firefighters and also our tactical operations. The Los Angeles City Fire Department has put together a strategic plan, and we achieved 3 of these within the last couple of years. Develop and implement a drone program, integrate the RS3 firefighting robot, which was influenced by the Shark Robotics Colossus. And then we've also purchased an electric fire engine, which goes in line with sustainable development goals, which we're trying to follow within our department. AI and robotics combined with traditional firefighting. As you know, within the fire service, a lot of tradition, a lot of culture that needs to be influenced. And that's quite a challenge. And it's a constant process for us to take firefighters who have been doing it a particular way for so many years and bringing in new technology and showing them how it's going to benefit their tactics and operations. Just an example of fire service tradition. That's our new electric fire engine. Once again, taking a look at sustainable goals, and we're the first in the United States to deploy that apparatus at one of our stations in Hollywood, and it's working out very well. Influence the fire service to accept AI and robots. Tradition and culture, as I mentioned, they talk a lot of our firefighters. You know, this is a way we've always done it, and it works. It's a responsibility of our leaders to influence new technology and change. Searching for subject matter experts, and we're finding a lot of interest within the younger generation in regards to technology and pushing the fire service in a different direction. We're being innovative, and within the organization, marketing the new equipment and tactics to the more seasoned, experienced generation appears to be working. It's a slow process, but we're making advancements. And then once again, evaluating the new technology, not falling in love with the plan, just making sure that it actually works and it's technology that we're going to be able to use for the future. This is an example of one of the fires that we've deployed our firefighting robot at. You can see all the firefighters squirting water, and that's a defensive operation that we've gone into. They were offensive, going inside the building. Me as the incident commander has determined that we cannot send firefighters in because of roof collapse. And at that point, we start directing hose streams from the outside. Well, we were missing one major component. When the roof's in place, ready to collapse, we were no longer directing streams on the inside. So this robot here has provided us with that ability to go inside the structure, continue to direct hose streams without putting firefighters at risk for collapse, as you can see in this picture, and continuing the firefight. Once again, influenced by the Notre Dame fire, which they went defensive and then eventually put a firefighting robot inside, which assisted with their operations. This is our How and How Thermite RS3, very similar in operation to the Colossus. We have a blade on the front, a dozer, which we can push material around. It has a thermal imaging camera on the front and a camera on the front and rear, so that the operator with a remote control, which you can see on top of that red hose there, operates. Some of the specifications of the RS3, we've got an 8,000-pound capacity winch. We're utilizing that for horse rescues. We put a gantry in place, and we're able to go into muddy areas and rescue horses. It's got a max stream vertical reach of 150 feet or 50 meters, and we can hit a football field about 300 feet or 100 meters. It's 2,500 GPM, weight of 3,500 pounds, and then length 120 inches, width of 65 inches, and a height of 64. So we can get it into most warehouses. There's a smaller unit that we're looking at that can go into smaller structures through smaller doors. And I know that the Colossus has the same capability. This is just an example of the reach that we have with our RS3. And we're going to be testing a electric firefighting robot technology that's utilized in the military. We're looking at this more for an application in the wildlands. So we'll be able to utilize this climbing steep hills, going on slope to the side, which our diesel motored RS3 is limited in. So we'll be taking delivery of one of these. We can transport equipment with it on that flat top and pull hose lines into the wildlands. So more to come on that. We're going to be taking delivery of one of these Boston Dynamics robots through Farmers Insurance. We're going to be testing it in hazardous environments, hazardous materials, and then also taking a look at structural integrity on collapsed buildings. So more to come on that. Our 2020 fire season, it was one of the worst fire seasons on record. We had 31 people killed, over 10,000 buildings damaged or destroyed, and 4.1 million acres burned. The North Complex fire, which I deployed to, was responsible for 300,000 acres burned and 16 people killed. And that's just a picture of our team out there after that wildfire went through that area and consumed so many structures in such a quick amount of time that we didn't know if people got out of their structures or not. So artificial intelligence and the ability to predict where fires are moving through fire modeling is the future, and it's going to save lives. This is some of the situational awareness data that we are utilizing now through the GAC. It's the Southern California Geographic Coordination Center, and it provides us with information on incidents throughout the nation, so we can see what the drawdown is on resources, how many resources we're going to be receiving on our incident. It gives us predictive services in regards to what the fire weather is and what the prediction as far as rate of spread is going to be. Gives us spot weather for the particular area, and then also what the fuels and the fire danger look like, fuel moisture, and what the dead fuel component is on these particular fires. Some fire behavior modeling. This is a Dixie fire. This was a fire that happened in the summer of 2021. And some of the areas of concern for us as firefighters is the weather, which is temperature, humidity, and wind. The fuel moisture and fuel type, like I was mentioning. What's a fuel model? How is this fuel going to burn? Is it dense? Is it sparse? Is it heavy timber? And then a big one is topography, slope and aspect for us in regards to the time of day and what that fire is going to do. Typically here in California, afternoon hours, we see in regards to our aspect, heating up on a particular slope will cause that fire to burn very rapidly. Doing spot weather checks, layering historic fires on maps, and then predicting the path of the fire so that we can have a really good idea of what our values at risk are, and also our evacuation plans. This is wildfire. We utilized wildfire in the Getty fire, which happened a few years ago. And we actually used it to plan our evacuation routes and figure out what type of values at risks or homes that were in the path of the fire. And this is all through artificial intelligence. We're able to figure out acres that were going to be burned at particular times, and then what the population was in regards to that area that was predicted to burn. And that allows us to set up evacuation sites, figure out paths of evacuation for the public, and it just makes us far more effective. So AI is being used quite a bit with us. And then once getting the information out to the community, we use Notify LA, and it picks up a particular area in regards to notification through hardline telephone and also cell phone, and then also through radio messages. And it gives early warning and also notifications in regards to path of evacuation and where people can find areas to seek refuge. Wildfire surveillance using AI. These are cameras that are placed on the top of mountaintops. Way back in the day, used to have a tower up there, and a ranger would sit up there with a pair of binoculars and watch for fires throughout the day and night. This is how it's done now. It's capable of detecting a fire within minutes and then transmitting the data back to a center to coordinate resource deployment and also develop satellite imagery and utilizing historical data and also mapping to predict where the fire is going to go and how we can deploy our resources. Predictive technology for the line firefighter. That picture down there with the red bag, that's how we do spot weather. That's how it was done many years ago. Still done to the day in regards to spot weather. But this gives us information through Fire Integrated Real-Time Intelligence System. It's an airplane that flies over the fire, takes the information, pushes it back to a center for processing, and then figuring out where this fire is going to go. It allows us to determine where the fire breaks are going to go, how we're going to evacuate the areas, and how we're going to deploy our resources. Our drone program. unmanned aerial system program. And also we're doing a photo kite evaluation, very similar. Well, it is a unit that Bart had explained to you. So once we pull up on scene, we put the photo kite up, we get immediate intel on what the fire's doing. And then as we need the more intel throughout the incident, we bring in our drone program, our operators, to map the fire and also figure out where we need to send resources. The drone use allows me as the incident commander to utilize the helicopters at first to do aggressive water drops on the hot flank of the fire. We're able to do the mapping and acreage determination with the drone, but also put the helicopter down on a pad just in case we need it again, eliminating flight hours on that helicopter. So we're also saving money on the maintenance of our helicopters by utilizing drones. And how do we bring this all together? These are our command and control units. It's a platform that we utilize. It brings all this intelligence, data, situational awareness together for the incident commander on scene of the fire so that we can make educated decisions and also determine tactics and strategy. We're reducing our firefighter injuries with the drones or with the robots, carrying heavy equipment back into areas that are very remote. We don't have to utilize the manpower, the staffing to do that. And then also being able to go into a structure after the fire is knocked down and do overhaul and mop up with the robots so that we're not exposing our firefighters to carcinogens and structural collapse. So in conclusion, bringing it all together, AI and robot utilization for us has been, early notification that the wildfires started, predicting our rate of spread, the path of travel, allowing us to be more effective as far as command and control, developing evacuation plans, assessing our values at risk, determining whether we go offensive or defensive with our operations. Like I mentioned, keeping firefighters out of the IDLH during overhaul and mop up, and then determining a effective time and a safe time to rehouse evacuees, and then bringing it all together is planning and the recovery for the community. Thank you.
Chief, thank you so much. Brilliant presentation covering much of the work that I'm very interested in and some of my favorite teams. So thank you. Excellent. Our next speaker, Arunima Sarkar, is currently AI lead, Center for Fourth Industrial Revolution, World Economic Forum. She leads the co-design of governance, protocol, and technology policy frameworks for artificial intelligence to maximize the benefit to society while mitigating risk and bias. She also leads the quantum computing governance mainstream developing principles and frameworks for responsible innovation and the use of technology. Arunima has more than 20 years experience in research, corporate growth, strategic initiatives, technology policy, and focuses on data, analytics, and AI. She is an expert member of the Global Partnership on AI's working group Responsible AI and has led the global applied intelligence research of Accenture and in multiple stakeholder communities around AI ethics and operationalizing AI ethics guidelines. And thank you so much. We need very much your opinion and perspective on bringing all of today together. Thank you for being here. The floor is yours.
Thank you, Kirk, and thank you to ITU for having me here. This has been really inspirational listening to all the work that all the fellow panelists have been talking about. I'll share my screen and talk about some of the work that's happening at the World Economic Forum. So I am part of the AI platform at the World Economic Forum, and we work across several initiatives around not only responsible AI policy, but also around using AI applications for social good, looking across various different sectors, etc. Fire Raid is one of the most recent initiatives that we have initiated last year in 2022, specifically looking at the application of AI and data for preventing wildfires. I think we've spoken about why do we need AI for wildfires, what are the kind of applications AI has for preventing and mitigating wildfires. And we have seen there are several statistics of wildfire spread, frequency and severity across the globe, several of the critical services being overburdened. And we can see that AI can enhance prediction, emergency response, and wildfire management capabilities. I think Chief White had many more AI applications in his final summary slide. So there are several applications of artificial intelligence that can be put to use in mitigating wildfires. And increasingly, what we are seeing through our communities of practice, that there is more global collaboration that could really help this all the ecosystem players to learn from each other, to share some of the AI modeling techniques, enable data sharing, enable transfer learning of the different approaches and mechanisms that are working in different regions, and really scaling some of these national initiatives at a more global level. These are some of the most obvious AI use cases that we have seen in interacting with wildfires around prediction, around emergency response, and wildfire management. And increasingly, what we are seeing is that there are new kinds of data types which are supplementing the old forms. So on your left-hand side, you see many of these new data sources. And again, our panelists have talked about many of them. And this wider availability of data has actually been opening up the possibility of training much more complex models. So we are seeing rapid advances in artificial intelligence and machine learning models that can be trained using these different new data sources. However, at the same time, as we speak to the different stakeholders who are grappling with this problem and working on the wildfire situations in their specific regions, there are certain barriers that most of them identify, which are a challenge in their journey to scale and create impact. And they are mostly around the data barriers, the AI and ML barriers, the computing barriers, the barriers around the availability of technical expertise and skills, the domain expertise and management capabilities, which can actually turn these AI insights into some policy-making decisions, and also the lack of awareness and trust in the existing data and AI tools that can really facilitate the adaptation efforts of these models. This is a very quick summary of some of the key things that we are hearing from our communities. There is a lot more detailed study available, which I'll just come to after this. So Fire Raid, what is Fire Raid? This is the initiative that has been launched by the World Economic Forum in Jan 2022. And we have been primarily working with two of our core partners, Koç Holding in Turkey and Deloitte. And this initiative serves as a global node and a facilitator of network of providers and users of data and AI solutions for wildfires. It helps in curating such AI efforts globally. It advances partnership building. It advances capacity development for governments and other firefighting resources. And it helps in the transfer learning, as I said, and understanding the development and deployment of new AI solutions to address this critical issue. And it we bring together several experts from technology companies, from governments, civil society, and international organizations who collaborate together and to try and understand what are the barriers to use AI systems for wildfire prediction and prevention, what has been working for them in their regions, how are they mitigating some of those challenges and barriers, and learning from each other. So this is a network of different experts that we have got together. So the first pilot, the work that was started in Turkey, forced into action by the worst wildfire season in Turkey's history. That is when one of our partners, Koç Holding, one of the largest industrial conglomerates in Turkey, who has been working with the Turkish Forestry Ministry, had proposed this initiative and of leveraging the AI platform to create an initiative which can finally be scaled to regions beyond Turkey as well, as there are several of our partners in different parts of the world who are grappling with this problem, who are dealing with this at a national level. But there was a need to bring all these partners together. So Coach Digital, they started with two broad AI models. One was a dynamic wildfire risk map that ranks the likelihood of forest fires based on seasonal variables. And second is a resource allocation that is based on many of the data sources and the wildfire risk maps. And in the event of forest fire, a first response wildfires in Turkey and some of the most high risk areas. This is a glimpse of some of the data sets that have been used currently by the Coach Digital project team in developing their models. Much more detailed information is again there in our report, which I will point to you shortly. There are various granularities of modeling which have been done. And this project community of experts has been discussing what are the right performance metrics that need to be looked at while creating such models. And in this case, Coach Digital looked at the recall for fire and no fire in events separately, and they achieved recall values of 0.8 for fire and 0.5 for no fire events. There are much more performance metrics available through their pilots. And the Coach Digital team is open to sharing their learnings, their models, and create open source repositories of these tools, and willing to work with different governments and different regions and share their expertise as well. So broadly, as I mentioned, the Fire Rate Turkey pilot was the first pilot that was conducted under this project. We have just concluded that this pilot in these few of the identified locations in Turkey, Coach Holding will now scale to other regions in Turkey as well. And after this, the plan is that we work in other climate similar situations. So there are certain countries in the Mediterranean region, for example, who have also been working on this problem and this wildfire issue. And they would like to pilot some of these models and approaches in their areas as well. And Deloitte, meanwhile, has also joined this initiative as a core partner. They have been working on some advanced modeling approaches, and they're midway in their piloting process. And soon we will be testing out some of those as well. So in terms of our approach, how do we get the different stakeholders to come together and collaborate? We create these multi-stakeholder communities. These are communities of learning where we get firefighters, we get technology experts, we get governments, we get civil society, academics to come together, share their knowledge, share their learnings, and join these community meetings, community workshops. Some of them volunteer to pilot some of these tools in their specific regions, and then share feedback as to how these approaches have worked. And we learn through these pilots, we aggregate these learnings, and then we scale it to other regions. That's the broad approach that we have been following. And these are some broad areas through which we try and achieve change, building awareness, informing the decisions, and driving collective action. This is what we aim to do through these large project communities that we curate. Just a week back, we released the first report capturing the Fire Rate Turkey pilot and the Deloitte approach, and also some of the approaches of some of our other partners like Google, NASA, etc. And it also lays out the path for the next phases of this initiative as to how we can take these learnings and scale to other regions. It's available on the World Economic Forum website. It's just been released this week. This is a broad roadmap of how we want to build this initiative. So we are looking at piloting now in other climate similar situations. We continue the scaling process. We continue to hold these community meetings, and I would love to have our panelists join and share some of their expertise in these meetings as well, because we have several experts from across the world who are volunteering their expertise. There are organizations creating open source repositories. We are trying to enable data sharing wherever it's possible. So there are various ways that the community is trying to come in and contribute to this initiative. So these are some of the various modes of scaling and contribution that I've listed here. This is an indicative list of some of the initial partners who have already been helping in this initiative. And this is a growing list. We are looking at working in other regions, and you could contact me if in case you would be willing to join this initiative. In terms of engagement, you can join the community, you can pilot some of these tools, and you can help us scale in other regions. So with that, I'll pause. Thank you.
Thank you so very much. It's inspiring to see more of what you're working on. The report that you mentioned that came out in the last few days has been sent to me numerous times by some of my colleagues, and great to get more perspective on that. Thank you. While you have the floor, Arunma, there's one of the questions that's come in today from the audience, and you touched on it a little bit. And actually Chief Wade was also mentioning about how we're a very traditional industry, the fire service. We still talk about the size and shape of the water from the fire hose, and the fire hose have been around 350 years. As we move into AI, and the question from the audience is, what do you think, and it's to both of you, what does a fire service need in terms of assurance for explaining or explainability and embracing AI in the public safety space, particularly for fighting wildfire? Arunma, would you mind?
Right. So that is, in fact, the sixth barrier on my slide as well. Building trust in these tools and creating more awareness around what these solutions can do and how it can really enable the firefighters in responding to some of this crisis. So that is one of the key areas that this community also wants to really address. And how do we build that trust with, that's an open question. That is one of the key barriers that we have listed and we need to work on definitely this year. I think Chief White would probably have a much more closer perspective on that.
And Chief, before you add maybe the jurisdictional perspective too, for me, it's generally education, getting the word out. This is available to us today. What if someone was able to share the location and they were at threat and the chief could action that intelligence and save their life, would they be willing to sell it, to share it? Yeah, not for sale, but that it's shared to rideshare companies and large corporations tracking our activities. How do we use that technology for good? Chief White, your thoughts?
Well, I think one of the major concerns that I've seen as we brought the robot into our fleet was the tension in regards to loss of positions and jobs. And I think with artificial intelligence and also the use of the robots, I think what we're going to identify is that we're not quite as effective in our deployment of resources and our models for putting resources out in the field. I feel that this is going to have the opposite effect and show that we're not that effective and we actually need more resources.
Well said. And we need not necessarily a digital native, but it might be, but regardless, somebody, a technologist in the field to assist incident command, because now we have data streams and we need to manage those data streams to enable actionable intelligence at the time of intervention. Excellent. Thank you all for being here. What an honor for me, and what a great learning opportunity. I'm gonna go back to Mano on that. We identify the use cases for Shark Robotics and these various solutions is both in the wild land setting and in our cities. Especially in recent times, we have wildfires in the city, which traditionally has not been happening for a few hundred years since some of the fire protection has been brought to bear. Would you please identify some of the fires, whether in the wildland or in cities, that your robots have been deployed to, different domains?
Yeah, thank you. Today, the use of a robot has proven to be very effective in many cases, such as warehouse fire, parking fires, or industrial site fires. In Marseille, for example, the robots are used 83 times each year. It's quite a lot. So if we take the example of warehouse fire, due to the risk of the structural collapse, warehouse fires are managed from outside the building, requiring a significant amount of water to drown the building. And thanks to the robot, it is possible to enter in the building, identify the hotspot, and extinguish the fire more quickly, thus consuming less water. And the stake is also environmental because it will limit the pollution of the air and the ground, and the damage on the company will be less. So it's very important. And in the case of underground parking fire, the use of a robot makes it possible to preserve human lives and improve efficiency in extinguish fires too, thanks to its multiple zoom and thermal cameras and various sensors by the firefighters. And in addition to this, there is also the issue of the increasing number of electric cars on the road, which make the action of firefighters more complex, and where the use of robots is an important support. And in the case of forest fire, because we talk about it today, we are still looking for ways to improve our robots in order to solve questions concerning logistics and connection to a water source. It's a big question. And this has not been seen yet, but we can imagine, for example, a line of robots that would protect houses for flames to support the action of the firefighters.
So much to be done, and so much good that can be done with them. Thank you so much, Mano. And it brings me back to Chief White's discussion for the interest of personnel. We don't need less personnel on the job. As a matter of fact, public safety in general, and especially the fire service, is struggling around the world. Volunteer organizations worldwide are closing because they don't have enough volunteers, and full paid career organizations don't have enough people coming in the door to fill those who are on their way out the door. And now we need robotic technicians. It's not going to take the job of the firefighter. It's going to enhance that really important work that they do, and we'll need somebody that knows how to handle that robot well. Thank you so much. Bart, a question for you on, there's so many unique challenges and opportunities for robots. And one of the, I'd like you to expand on where you see challenges and progress. In specific, one of the questions that came in online is the height, that you have a given height for the robot. Certainly in my community, there are trees that are quite tall. Any thought on increasing the height range of your system? Thank you.
Yeah, thanks for the question. It's actually two questions. I mean, the height is not limited by technical capabilities. It's more a regulator thing. I mean, there's a ceiling up to 50 meters. So the rules change when you go higher than 50 meters. I know that some of my colleagues are also in the audience. When I say we can easily go up to 100 meters, they will say, well, don't overpromise, but 50 meters is definitely not the limit. I think the second part of your question was challenges. few years ago, it would have been ease of use, operation in rain, windy conditions, batteries, I mean, to stay in the air, to promote PhotoKite a little bit, especially on the battery side. I think we ticked the box on many of these items. Wind will always be a challenge. How good your robot or your drone is, I mean, you also know from your own experience that the wind can be extreme. So that will always be a challenge. But on the other hand, that is also an opportunity when you're talking about safety. It's better to have a robot in these conditions than a manned vehicle. So we see it as a challenge and an opportunity at the same time. But I would say to summarize, wind will be a theme for the next few years, even with AI.
Yeah, absolutely. And there's a duality. The challenge and the opportunity are either side of the same coin. We're going to keep going with some question and answer, but I know, Arunima, you are short on time with other important work to get to. Thank you so much for being here. I understand you're going to have to depart, and thank you. For the remaining remaining panelists, there's a question on thermal imaging, specific to monitoring hotspots, and can that, or are we doing that? And I can say for sure I'm aware of some, and I would follow Arunima's work with some of the big teams at a very high level. Unless she mentioned NASA and Google, they're doing incredible work with Earth observation, hyperspectral infrared, all types of imaging from space. And then we can come down to granular levels with the work that you all have been doing. Anyone in particular done some work on AI? Bart, I see you're off mute. Would you speak to the IR capabilities, range and related on your Kite?
I'm not even sure I fully understand your question. The question is
monitoring hotspots in the wildland. Are we able to?
Okay.
You've mentioned that a little bit about structure, but just a little more on that. How effective is that? What type of range might you have?
Okay, range. That's the word I missed. Sorry about that. Well, I mean, it's part of our offering. I mean, it's situational awareness. As I said, we have the camera. We can even measure the temperature. So hotspots, easy to detect. Flying at a height of 45 meters. Range is in principle not a limitation for us. I mean, we're really talking a long range. I mean, with wildfires, we didn't do tests, but with buildings, we can cover the whole area, which is on fire. As I said, what normally is done, and we know from end users, is that they then use multiple kites, also to approach it from different directions. But for us to see the hotspots is well, you were talking about challenges. That's not a challenge for us anymore. It's more, what do you do with the data, and how quickly and how easy can you get it to for example, you, Chief White, when you're in your command vehicle, how easy is it to get all these signals and to respond to it? That's more of a challenge these days.
Agreed, and a lot of data management. And when you mention multiple kites, some of the teams I'm aware of are using remote sensing techniques from LiDAR and structured light sensing, nerves, and other things to build a 3D map of the scene live, effectively. So inspiring times. Thank you, Chief. Do you have something you wanted to say on the infrared range and capabilities?
We're utilizing our helicopters with the FLIR, the forward-looking infrared, and then through a downlink, we can send that to that command vehicle that I showed you a picture of. And in saving the flight hours for the helicopters, we'll ground them on a high point and then bring in the drones, and we can fly the perimeter of the fire and downlink the thermal imaging data to that command vehicle also. So it saves us flight time, and also gives us unlimited evaluation of the perimeter of the fire to make sure that we don't have any flare-ups.
Brilliant. And yeah, I know the helicopters is feeding into Virus, and also some teams are using the team awareness kit or CivTAC as an open source common operating picture, and the thermal can be propagated to that as well.
Right.
Right.
Virus, right, the downlink, it can figure out where there's ember cast that has gone ahead of the fire, and we can get that information also.
Excellent. We might, maybe when we transfer over to the neural network, we could put a couple links in there, at least for follow-up. We'll make sure we get that done. Chief, while I've got you on the line, also, how might you see how governments and organizations and individuals, because we have a range from individual people up to big, 100,000 member teams that really we want and need in this space. How might you see them getting involved to use AI and robots for the work you've been starting? Thank you.
I think it's a fascinating time where we're probably going to see a real blend, the collaboration between folks that are developing the AI and us, the boots on the ground, and figuring out how to bring the two together. So all I can say is keep doing what y'all are doing, and I think what's going to happen to this, like I said, this is all going to blend together, and we're going to have a very robust common operating platform. And like I said, I think we're in a fascinating time right now.
Indeed, and there's so many inspiring questions coming in from the chat. We'll go a little bit longer, and then we'll jump over and do a little networking in the neural network. Mano, for you, please. So intelligent robots, how do you see them fit in the broader context of the UN's Sustainable Development Goals, and maybe in particular in protecting the environment? But thoughts on that?
Yes, just for me, robotics coupled with AI is a new technological revolution. And some people tend to caricature this sector whose benefits are obvious, especially in dangerous environments. And involving a robot rather than putting humans at risk seems natural. And some experts talk about the 3D of robotization to say that robotics is relevant for dirty, dual, and dangerous tasks. And here we are in dangerous tasks. And at Track Robotics, after several years of use, we realized that our robotics has a triple impact: that protecting humans, protecting the environment by reducing the water consumption and limiting air and soil pollution, and protecting company when we know that 7% of the companies which are victims in a fire register disappear the months which follow. So we must see a robot as an additional tool, obviously, at the service of human beings.
Thank you very much, Mano. Here we have a combined question from a colleague very interested in smart cities and smart regions work, and another question that are aligned on. It's been said in the fire industry that the best way to fight fire is to prevent it. If we have ignition and an uncontrolled fire, well, we've missed something. So are we seeing robots just for response? And I know the answer is no. So how are we using robots and AI to prevent fire in advance?
I'll take a stab at that. So when I was talking about blending the AI with the robots reason through an operator, like I said, I feel that link there needs to be improved upon, needs to be developed so that we have the technology going to the robot and figuring out what is going on from an intelligence standpoint. So there's that part of it. But as far as the density of the forest and then how do we limit that density through proper fuel management, that's a tough one there. We're looking at prescribed burns that get out of hand. There's a lot of environmental issues, but I think that the density of the forest is a contributing factor to some of our mega fires that we're seeing. But I believe that the AI and also predicting where the fire spread is going gives us a jump on where that fire is going to go, so it doesn't turn into a mega fire, and we're able to basically guide it where we want it to go. So I think AI is going to contribute during the firefight. It's also going to give us predictive services prior to the firefight and pre-planning for our forest.
Absolutely, Chief. There are a few teams that I'm aware of that are monitoring everything from, you mentioned fuel on the ground, monitoring it in 3 dimensions, if you will, through laser scan technology and other things that identify the canopy height, the density, as you mentioned before, slope aspect, and some that are doing this from space with up to 12 different parameters to identify where's the most likely place for ignition. And if we know, say, across a given county, the 10 spots that have the highest probability of ignition, we could send personnel out there and see what we can do to mitigate those problems. On the fire modeling, where do we deploy our resources in advance? So where, as communities are built out, where a new fire station is built, a new firehouse, is an ongoing question, and AI can help us with that projection. And I would mention some of the work that NVIDIA and Lockheed Martin are doing, along with some other partners, on fire modeling, using AI to ingest empirical data from mixed physics computational fluid dynamic models with millions of lines of code of past work that how do we constantly improve, continuing quality improvement of our AI models. So great questions coming in from the audience. Thank you for everyone, and to our speakers for being here. I want to give everybody a chance. And any final comments for us before I have a few things to close with, but Mano, Bart, Chief.
Yes, I see a question about prevention and not intervention. I would like to say that the main challenge is to intervene the more quickly possible, and because everything happens in the first few minutes. So if we have a new technology which can intervene very quickly to avoid a big fire, is very important. So we can prevent, but we can intervene very quickly, and for me it's very important. And I would like to respond to another question I see about the remote control robot and the integration of AI bricks. And I would like to say that at first we began to develop remotely control robots because it was important for the firefighters to control everything on the robot, because using robots is not natural, because before 2015 nobody used robots, so it wasn't natural at all. So we have to convince the firefighter of the necessity to use this robot, and the AI bricks will follow after. And we can help the firefighters with navigation aids, with AI bricks like follow me, like go back to your position. It can be very useful, but the decision maker will be always the firefighter. And it's very important to say that too. Thank you, Kirk.
Oh, thank you very much. Thank you. Bart, Chief, any final comments or any questions I might have missed that you wanted to target?
Well, I think overall it's clear that there is a positive movement. I mean, sometimes the topics are discussed and it's seen as a start. I mean, if I look what we presented, but also if I look at all the questions, it looks like everybody is convinced that robotics, AI are the way forward. I didn't see any negative comments. I also think, and that's maybe another focus also for companies like Kite, but also for Manon, is to offer it at a lower cost. Preventing, yes, but then that means that you also need to invest in it. So I think apart from technology, we should also look at making it affordable, because yes, there are big cities with big budgets, but we also have a lot of customers coming from smaller cities, not having a huge budget, but having the same dangerous situations. So I think that is something for the future.
Agreed. And there's considerable dialogue on the need to divest in legacy technologies and invest in next gen. We are moving into next gen, and it's time to move from land mobile radio, two-way voice into new systems. Chief, final thoughts?
Yeah, in regards to the funding, that was a challenge we ran into when we were getting ready to purchase the RS3, the robot. And we utilized our LAFD Foundation through a donor group that put together money to purchase that robot through a company by the name of MES. So it's a challenge for smaller organizations. It was a challenge for us. Do we buy a fire engine or do we buy a robot? So that was a path we headed down. And we also fund a lot of our additional equipment above and beyond what the standard firefighting equipment is through donors, and it's working out pretty well. One other thing, I'm honored to be here. I'm surrounded by a bunch of very smart people, and I appreciate what y'all are doing to make my job easier and safer for not only the public, but also for our firefighters. So thank you all. It's an honor.
Thank you, Chief. And with a previous perspective of 1,400 apparatus, you're the great person to lead that discussion on, is it a fire engine or a robot? Because we need both. So thanks for leading the charge, leading the way here. Huge gratitude from myself for the opportunity to support this work today and to moderate the panel of very esteemed speakers. I have a few closing thoughts to consider from this, and because today it's possible to build a metaverse style life-saving platform, and our discussion today focus on smart cyber physical systems that frankly I've long imagined. Instead of painting pictures with words to an emergency call center in someone's time of need, it will be replaced with digital solutions. Systems that will provide critical information during life-threatening, time-sensitive events. Smart robots are a part of that modern ecosystem that comprise command, control, computers, communication, and those cyber-physical systems. They're systems of systems engaged in three-dimensional building information modeling, biotelemetry, mixed reality, computation, or computer vision for a multi-sensor fusion-enabled life-saving and property and environment protecting systems. Thank you all for being here today and seeing how robots and AI are an essential component to that. Many challenges ahead, yet these tools will support many of the strategic sustainable development goals. And thanks for encouraging the panelists and the efforts of fighting fires with robots. Thank you to the panelists again, the host team at the International Technology Union, and the United Nations members who support AI for good. On behalf of all of us, thank you for being with us today, and please join us on the Neural Network.
Thank you, thank you very much, Kirk, and a big thanks to all our speakers today, Manon, Bart, Wade, Arunima, as well as to all the participants for making it such an interesting discussion. And now we encourage you to check out the AI for Good program online to see more robotic sessions that may be of interest to you. And this is the end of this section and the start of the networking in the AI for Good neural network with the panelists and participants for the next 9 minutes. So see you all in a couple of minutes now, and I give the floor back to Anna for the closing information. Thanks a lot to all.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the e-shop, and build your personalized AI for Good program. Let's shape the future of AI for Good.